This book is very, very, strong one, actually. I attacked it twice, actually. It was 3 weeks ago. I usually, my kind of, treatment is if I feel my body is affected by the germ, I go out and run, actually, 20 kilometers. Or I go to gym and then doing squat. Pillow squat is squat 300 times and then push up 200 times. And then finally I'm doing 100 lift up actually. And I can feel the germ actually gone from my body. I did the same thing 3 weeks ago. I can feel my body is totally, invaded by the germ. At that night, I was almost killed. It was very, very different, types of the. I think it was influenza. And then next day, I was almost, lying in the bed. And afternoon time. Well, my body also needs some more heavy training. So I went outside and run 25 kilometers because I should do some training for Seoul marathon a couple of 3 days ago actually. I finished it, fortunately. And then I can expel the germ 3 weeks ago. Then 1 week ago, my wife seemed to be affected by the virus. She just told me her throat is very icky, and I just told her, "What? That is very simple in the cold, and if you have some drug, you can get it better." Well, I just, because my place is located in Seoul area, I just moved to the bedroom. And then, last Tuesday, my body also felt very, very, heavy, and I can sense the germ re-attack me. Well, I really don't have any, intention to do some heavier training again, because I know that can kill me again. So I just lie on the bed, and 3 days actually. So I really don't know what make the virus so strong. Any guys here is being in cold or flu right now? Yeah. It is just like your body is totally, attacked by the germ, and it starts with the nose and throat actually, and then it spreads. And most of the strong. Well, most of you are all 20s, right? Is there anybody more than 30 years old? 40? Like me. Anyway. You really need to have some antibiotics. This is very, very important. Go to hospital and have some prescription and take the antibiotics. How the antibiotics, affect the microorganisms? Do you know that? Chemical nature. Do you know that? How the pharmaceutical chemical can inhibit the reaction occurred by the organic molecules called virus or called flu.
Inhibit transcription of translation. inhibit mechanism of RRA or something.
Maybe some of you think the drug can directly kill the virus, right?
So they produce antigens or something like that. Anticoagulant in French. They produce some chemical that are going to affect the medicine released from your body. Will prioritize the production of some Y-shaped thing. I don't know how to call it in English, but then they will attack the...
Yeah. Well, that is part of the reaction mechanism, actually. Some of ACE drug, AZT is kind of very smart drug, actually. The first generation of AZT just to block the inhibit inserting the virus's rag into the cell, T cell. So it just blocked the whole virus's rag, and if he put through his leg into, why I say his leg into a cell, and they can exude some kind of chemicals so that they can thrive. But AZT actually blocked the hole, so it cannot, getting through his leg into the cell. The problem is the virus is not that stupid, thing. It evolved actually. If the AZT block the hole, it can find another hole actually. So it can be mutated actually. So if the pharmaceutical scientists develop the new drug, actually the virus evolved. That is very interesting, right? For the pharmaceutical scientist and the scientist, such kind of wall between the simple virus and is very, very interesting. But the people who are affected, well, that is very. Well, anyway, so Michael have some prescription and take some, antibiotics.
Already.
That is very, very important. Just don't drink with the soju with pepper powder. That can kill you. All right. Well, we are doing CO2 equilibria to calculate the pH of the rainwater. We have talked about the logarithm here. pH equals minus log the concentration of H, which is hydrogen concentration. So, and then we know if we put P, small p here, that means minus log. So we can put it P with the Ka, which is equilibrium constant. So you can have pKa value. If you check the CRC handbook or other type of physical chemical handbook, you can find out a bunch of pKa values, which is very, very important to only chemist and only environmental scientist. Well, and also important to the environmental engineers and chemical engineers, because they can give you some kind of approximation and estimation for the concentration of final product. That is very, very important. So pKa. So the reason why we put P is we don't want the long, complex numericals. We just put it P, and we can have here the 10 actually removed out, and minus 4.76 we get here. And then we have talked about the kinetic lag constant, right? So kinetic lag constant here. I want to also introduce one more concept, which is a little bit different: equilibrium constant. You may be very wondering, what spot you want to use equilibrium and what spot you want to use kinetic. But environmental engineering and environmental science equilibrium and kinetic also important. Why this is important? Miso? Why do you want to use equilibrium and do you want to use kinetics altogether? What is most important thing in environmental engineering? Let's say you graduated from KAIST with very good grade, maybe cum laude or any kind of very good students, and you actually enter the Montgomery Watson. That is very big environmental consulting from the United States. Well, actually, that is multinational, environmental consulting company. So, if you are employed there, what is the most important standard for you as an environmental consultant? I think I already told you about that.
Money and time.
Yes, right. So kinetic is related to yes, and equilibrium related to why?
I think equilibrium is related with concentration of something.
Mm-hmm.
So concentration is related with amount, and amount is related with money. So
that's right. That's right. Well, if we are, as I already told, if you are the pharmaceutical scientist who is in Pfizer, if you are developing new ACE drug, if you know the rate constant for the reaction to make AZT, you can actually estimate the amount of AZT. If you know the pK value of that reaction. So equilibrium is important for the money actually. So that is very, very important thing. Here, the K value, equilibrium constant actually explained by the product ratio between products and reactants. This is very simple. And most of you know, actually learned this from middle school and high school chemistry. And there are so many different types of equilibrium constant. Well, equilibrium constant is actually, how can I say, partitioning coefficient. Partitioning. What do you think about what is partitioning? Have you heard about partitioning? Yes. So let's say if you just put the salt, sodium chloride, into the water, well, sodium chloride actually dissolve in water, right? But as a physical chemistry side, salt actually partition to the aqueous phase. Solid phase salt actually partition into the aqueous, water. Another thing is, let's say, this is salmon, right? And then this, stomach side, and we want to measure the concentration of polychlorinated dibenzodioxane PCB, call it dioxin, from this salmon. What we should do is just take 1 gram of its flesh and then put it into the hexane or pentane, which is non-polar solvent. Polychlorinated dibenzodioxane. Well, poly means many, right? So P, poly, and C, chlorinated. So there may be many chlorinated around here. And then the dibenzo means this is benzo. And there is 2, dibenzo and dioxin. this is the most, harm and the most dangerous chemical compound which humankind have ever made. So, well, we want to actually measure this one. In that case, this one, the pressure 1 gram actually salmon pressure into the hexane or pentane, let's say 10 milliliter solvent, and then mix it vigorously. Then this very small amount of the PCDD in the fish, it can be partitioned into the non-polar, because this chemical is non-polar. What is polar and non-polar? Water is polar, so it can dissolve the salt, right? Non-polar, oil and gasoline, it cannot be easily mixed with the water, right? So we can call it non-polar. So non-polar chemical compounds can be dissolved in non-polar solvent, and the polar compounds can be easily dissolved polar solvent, just like salt in the water, and this chemical PCDD in the non-solvent hexane. If you just mix it, and this chemical can be partitioned into the liquid solvent. So in this case, partitioning occurred between solid into the liquid phase. So this is partitioning coefficient. Or we can say K OW or K something chemical or something chemical. So this is partitioning coefficient. Well, actually, partitioning coefficient is one of the equilibrium constants. All right. Well, I think you guys can have much more information at chapter 6 or chapter 5. I think there is some, that information there. Right, and then the other one is KW. What is KW? Have you heard about the KW? KW is right, and then 10 to the minus 14, 0.00. Molar dissociation coefficient, constant. And because you put P minus log, you can have 14. And then I introduced you the Henry's law constant. I think I gave you a little bit long information last class. Well, there is two types of Henry's law constant, with units and without units. Here, the author actually introduced you with the units. Henry's law constant, KH equals concentration of X in water divided by partial pressure of X in air over the water. Well, as I already talked, this is just a pure water, 10 milliliter, and then just a spike, 1 microliter of 99%. Well, C2H5OH is ethyl alcohol, right? So, well, actually, I have 99.995% very pure ethyl alcohol. Well, if you want to have some experience to drink it, well, because this is very pure alcohol and very expensive. Well, anyway, just a spike, 10 microliter into the pure water, and then what you should do is just shake it vigorously. and then stand it a couple of hours. And what happened is there's partitioning occurred, right? Alcohol, it can be easily evaporized. So alcohol here, the alcohol molecules actually well mixed, and then it can be evaporized, right? Then maybe a couple of hours later, if the partitioning approach to the equilibrium condition, you can measure the partial pressure of alcohol at the headspace. And then you can measure the concentration of alcohol in water. Then divide it by these two amounts, and you can have KH value. But sometimes, you guys can use, you guys can measure the gas concentration of alcohol in headspace, and then you can measure the alcohol concentration in water. In this case, these two concentrations can be, canceled out, and you can have unitless Henry's law constant. But in this case, you are using the partial pressure. You can have Henry's law constant with the units. Here, the units are mole per liter per atmosphere. All right. Using this basic information, let's calculate the concentration of hydrogen, proton, in pure rainwater. The first time, the question is, what is the pH of rain found in pouring through an atmosphere free of anthropogenic pollutants? Well, as I already talked, this is just God-made type of the rainwater. And then remember, the concentration of CO2 in air is 360 ppm. Using this information, with some chemical reaction and some mass balance equation, we can calculate it. The answer is not 7 actually. So this is the reason why the board people don't want to go out during the rainy day. Rather, it is somewhat lower due to the presence of CO2 in the atmosphere. Everybody knows CO2 in water can be dissolved a little bit amount and can form carbonic acid. So this may be around the 5 point something like that. So you know the concentration, but we are actually scientists, so we want to calculate it, the value actually. Okay, let's look at it step by step. At first time, CO2 dissolved in water. This can be controlled by the Henry's law constant value. CO2 air and CO2 water, CO2 in this atmosphere. If you just spray the water, and the water CO2 in the air can be dissolved in that water spray. Actually, using the Henry's law expression, CO2 concentration in water divided by CO2 partial pressure in the atmosphere, and then we actually know KH value. Well, you guys can actually measure these two by experiments, but the scientists already did it, So you can find the KH value at CRC handbook, which is 10 to minus 1.47 mole per atmosphere. At this time, although I have very strong interest reaction of the chemical species in interface, I'm not gonna teach about the chemical species. Some textbook, CO2 dissolved in water, presented by carbonic acid or carbonic acid star. Ronald Heights actually think this is wrong, but I think this is right. Because chemists actually think this is a little bit, real expression, but as an engineer, this is much more, proper for the estimation actually. Do you know why? If you want to know why, first have the CE517, which is advanced environmental chemistry, which is graduate actual course. Well, anyway, using this expression, and then we can calculate the CO2 concentration in water. So here 10 to minus 1.47, and then 360 ppm. You can have 10 to minus 4191 molar here. Okay. And then we need to think about the. I just want to ask you, technically, if you just add acid, let's say hydrochloric acid, what kind of chemical species stay in the solution?
Water.
Okay.
H plus,
Okay.
Cl minus,
Okay.
and HCl.
Okay. Wow, this guy really knows much. And then?
Then nothing.
Right. Wow, that's very good approach. Think about this. I will start with the CO2 here. Well, if you just add CO2, well, as Ron Heights said, H2, CO3 can be formed actually. But is this all? But there should be, CO2, because here, H2O, it has H plus and OH minus, right? So you can react with CO2. So you can have HCO3 minus, and you can have CO3 minus. And some cases you can have very small amount of the hydroxide. Wow, it is really, really interesting, right? Although the pH is around the 5 point something, you can have hydroxide, maybe 0.000000001 millimolar. Yeah. This could be. So, well, actually, if we want to calculate this concentration, we actually need to identify all of the chemical species concentration. As an engineer, I will just tell you what's the difference between engineer and scientist. All right. So, we want to actually use the first equation. CO2 actually dissolved in water. It can form bicarbonate and proton, right? And then using the equilibrium constant expression, you can have this one. Here, H2O is 1, so you don't have to put it H2O here. And then Ka1, the value, you can find it as CRC handle. As I already talked, environmental scientist and chemist, well, maybe 18th century and 17th century, if they calculate this and then put it in the paper, that is kind of doctoral thesis for them at that time. Maybe, it is just like the 1950s and 1960s. The mathematic major, if he can solve one differential equation, he can get a PhD. At that time, no more. Nowadays, though. And then rearranging this one and substitute CO2 concentration, you can have this nice, the first mass balance equation. no, actually equilibrium equation here. And then, as I already talked, this is not the ending. Well, the chemical species can be changed with respect to a pH, actually. So this is just like this. This is concentration, and this is pH. And just this. So here we can call it pKa. pKa 1, 2. So CO3. So here you can have H2CO3 this amount, and then this amount of the H2CO3, and here you can have this chemical dominant chemical species. Okay. So we also want to consider another reaction. When CO2 dissolved in water, it can produce not carbonate, not bicarbonate, carbonate. So the bicarbonate can be dissolved in water to the carbonate and the proton. So using the equilibrium expression, you can have this equation, and you can find the Ka2 value in CRC Hamilton. And then rearranging this equation, you can have the final, equation 2 here. You have equation 1, and this is 2. And then finally, water dissociation constant, which is HOH product equals 10 to minus 14. So you can have 3 equations, right? This is very, very important. And then, to the mass balance equation. Well, there are 3 ways to set up mass balance equation. You can use Tabulo and Lasby, which is much more, environmental engineer-like, approach. But here, because we are doing actually environmental science, I'm doing with the scientist way. Well, there is some, charge balance law. So that means, well, let's start this. In raindrop natural system, there must be the same number of negative charge and positive charge. So in this, atmospheric system and aqueous system, if there is this amount of negative charge, there is this amount of positive charge. So it always, equals. So using 3 different equations I already showed you, and you can have proton, and you can have bicarbonate, and you can have carbonate, and also you can have hydroxide, right? Well, this one is the equation number 3. So you have hydroxide and proton, and this one is number 2, and carbonate and proton, and also here you can have the bicarbonate and proton. So using all of 3, you can have this nice mass balance equation, because this is the balance of carbonate is 2, so you need to put it 2 here, right? It can produce 2. While all of the proton and bicarbonate, hydroxide, it can produce 1. So you need to put it 2 here. And then using equation 1, 2, and 3, you can substitute each items here. Then finally, you can have hydrogen, or the equation can be transport it to the transform to the all the proton concentration. Well, if you see this equation, what do you want to do? Can you solve this equation? Juntae, can you solve this? You cannot solve this? Man, you guys can learn how to solve this equation from high school. Maybe second grade, I think. No?
잘 올려서 어떻게 한다면 되죠.
If so, you're already in the college right now, and you may learn how to solve this one using numerical analysis. Or have you ever tried to solve this not linear, just algebra problem using some kind of software? No? Oh, shame on you. I think algebra and calculus and also numerical analysis is very, very important. You guys really need to run that with statistics. Because you are here, you really need to run that. So have numerical analysis. Well, as I already taught, if you are using Excel or if you are using SAS or SPSS, you can find some kind of solver. Have you heard about solver? Solver? 경연? No? If you are use solver, it can use least square method, and then it can actually give you exact solution. Important thing is you need to at first time you need to take one guess. If the guess is very good, and you can have the solution in a very short time. If the guess is not good, well, sometimes you cannot get. But anyway, you can get it. Least square method, I think you guys can run a least square method from statistics. Yeah, break dancer. You know that, right? Yeah. Okay, great. Well, so I think this is how the civil and environmental engineer usually want to solve the problem. But you guys can be a little bit, shocked by the low heights. This is how the environmental chemist or environmental scientist want to calculate. They are very good at approximation. Here. The hydroxide term, well, this is the rest term at the previous equation. Yes, here. This one is very small. And this is almost the 630 times smaller than the first term bicarbonate. So this is not insignificant, right? So just to remove that. Well, to think about that, if there is, one, let's say, like this. Well, if you want to simply calculate, you just want to remove this one, right? The same thing. So you can have a much more simpler equation by multiplying h plus square, and you can have h plus cubic and this one. And then what he did is just put the pH 6 here. Which one is much lower? This one, right? So let's just remove this part. And then you can have very simple, equation here. Then you can simply actually calculate the concentration of the proton. This is what the scientist is usually doing. Is this right, Jimmy? What do you think about the chemist over there? Do you do this?
Yes.
Yes, it is.
And I guess I'm not chemist.
Well, I think you'd better, if you want to use numerical analysis, I think your preference is, I think, in the engineer side, actually. So, as I already talked, engineers really want to calculate. You should calculate, not the approximate. Never ever approximate. Per digits are very, very important to us, which is very, nothing to the scientist. Anyway. And finally, you guys can have the pH of rainwater is 5.63. Have you ever tasted the water with pH 5.63? You just open your mouth, when it rains, and you can taste that actually. But I don't, be sure, that is pure water. It can be fully contaminated with the germs and the toxins and lots of things. But when I was a graduate student in the United States, the area is Texas and very hot. Almost the temperature is around the 40 Celsius degree. During the winter day, it is just like the 20 Celsius. One day, I can see it snowing actually. So all of the students went out and opened their mouth, and it snowed. It's now contaminated with a bunch of chemicals and a bunch of germs, So, as I already talked, you guys can be very afraid of the AIDS patient and the patients, because they can actually affect some germs to you. But the important thing is there are much more cases, dangerous cases, compared to the germ attack, the chemicals. You can be that actually. It is just like if you are smoking, it is just like I cannot say this one to you. It is much more dangerous to sleep with AIDS patient actually. This is very, very important thing. Don't forget that. And next time, I will add more contaminants, sulfur, and also NOx. And then you guys can calculate, not approximate. Any questions?
Exam hour 10 to 12?
10 to 12. Well, I think this is for the student representative role. So, you guys stay here and discuss the time and the place, and then let me know. Anything else? Tom? No? Thank you very much.